pyrimidine, it is another diazine. So pyrimidine is a 1,3-diazine, or we can name it as meta-diazine. So it is a 1,3-diazine. It is the important member of the three diazines. It is also less basic than pyridine. So pyrimidine also contains two pyridine type of nitrogens. However, it is less basic compared with the pyridine. So pyridine is the most important member of all the three diazines. So 1,2-diazine, that is pyridazine, pyrazine, and pyrimidine. So pyrimidine is more important compared with pyridazine and pyrazine. So pyridine is a symmetrical diazine. Pyrimidine ring system occur widely in living organisms. So pyridine ring, it is a part of the nucleic acids. So it was first isolated in the year 1899. So pyrimidine ring is a part of many useful drugs. So it is a colorless solid. Pyrimidine is a colorless solid having a melting point of 22 degree centigrade. So it is weakly basic compared with pyridine and imidazole. So imidazole itself is more basic than pyridine, and pyridine is more basic than pyrimidine. So coming to the methods of synthesis. So the first method is from barbitoric acid. So pyrimidine was first prepared from barbitoric acid. So barbitoric acid, and it is the keto form, and it is converted to the enol form. So enol form is treated with phosphorus oxychloride, where the OH groups are displaced by the chlorine atom, and this on heating with zinc dust undergoes dehalogenation. Dehalogenation. So halogen atoms are removed. Halogen atoms are removed. So it forms pyrimidine. Next, from alkyl pyrimidines. 4,6-dimethyl pyrimidine on oxidation gives the corresponding 4,6-dicarboxylic acid, so which on decarbonylation gives pyrimidine. So these alkyl groups, the methyl groups are oxidized to carboxylic acids. This carboxylic acid can be removed as carbon dioxide by heating with a base or calcium oxide. So carboxyl groups are removed as carboxylic acid to form pyrimidine. Next, third method, from amidines. So reaction of amidines with diketones or ketoesters or malonyl esters in presence of sodium methoxide gives pyrimidine derivatives. So this is 1,3-diketone. 1, 2, 3. 1,3-diketone is reacting with amidines in presence of sodium methoxide to form a substituted pyrimidine. Next, from alpha beta unsaturated ketones. So alpha beta unsaturated ketones react with amidines to give pyrimidines. So alpha beta, this is an alpha beta unsaturated ketone reacting with amidine. So with loss of water molecule, it forms a dihydropyrimidine derivative, which on oxidation undergo dehydrogenation to give the substituted pyrimidine. 2,4,6 triphenyl pyrimidine. These are 4 different methods of the synthesis of the pyrimidine and its derivatives. So, chemical reactivity. Coming to chemical reactivity. So, the 2 nitrogen atoms which are present in the pyrimidine ring are electron withdrawing, like that of the nitrogen atom in the pyridine. This makes the entire ring system electron deficient. Therefore, substitution of electrophiles in the pyrimidine ring system is difficult. However, if activating groups are present in the pyrimidine ring system, then it may undergo some of the electrophilic substitution reactions. Pyrimidine ring is deactivated. That electrophilic substitution does not take place. So, pyridine ring is deactivated because of the presence of electron withdrawing nitrogen atoms. Therefore, substitution of electrophiles becomes difficult in the pyrimidine ring system. However, presence of 1 or 2 electron donating substituents like OCH3 counteract the electron withdrawing effect of nitrogen atoms, and in such cases electrophilic substitution occur at the 5th position. This is an example. A pyrimidine ring containing a electron donating amino group. When an electron donating group is present, so the ring is activated towards electrophilic substitution. So chlorosulfonation, it may undergo the chlorosulfonation, and the chlorosulfonic acid group is found at the 5th position of the pyrimidine ring system. Therefore, by substituted if 1 or 2 substituents are present in the pyrimidine ring system, which are electron releasing, substituent must be electron releasing, then it will activate the pyrimidine ring system, then it can undergo some electrophilic substitution reactions. So this is nitration. So pyrimidine is converted into pyrimidone, 1H, pyrimidone. So then if we write this is keto form. If we write the enol form, we get OH group here, which is electron releasing. Then the ring is activated, and then it can undergo nitration. Nitration occurs at the 5th position. This is a keto form. Structure is written in the keto form. Nucleophilic substitution. Substituted pyridine can undergo aromatic nucleophilic substitution by displacing these leaving groups. So, for example, 2-chloropyridine on reaction with aniline gives 2-anilino-pyrimidine. So, this is a leaving group. Chlorine acts as a leaving group, and this amine will attack as a base at this carbon. It is a aromatic electrophilic substitution. So, this 2-chloropyridine on treatment with aniline forms 2-anilino-pyrimidine in a aromatic nucleophilic substitution reaction. Reaction with oxidizing and reducing agents. So pyrimidine, if it is unsubstituted, pyrimidine gives a low yield of an oxide on oxidation with peracid. So when pyrimidine is treated with peracids, it forms an anoxide, but it is not stable. So the ring is largely destroyed during anoxide formation. That is, the pyrimidine ring will be destroyed during the formation of anoxide. But if there are some electron releasing substituents like alkyl groups, so alkyl pyrimidines gives a stable anoxide. So for example, 4-methyl pyrimidine when treated with hydrogen peroxide, it forms an oxide. So, however, here we must note that only one nitrogen atom can form the oxide. So 2 pyridine type of nitrogens are present, but only one of them can form the anoxide. So thioclizin rearrangement. Substituted, this is another reaction, thioclizin rearrangement. So substituted thiopyridines undergo the familiar thioclizin rearrangement. So for example, 3-methyl 4-allyl thiopyrimidine 2-one on heating gives 5-allyl 3-methyl 4-thiouracil. It undergo a Claisen type of rearrangement. We can see here it is the bond cleavage takes place here. So it is migrating to this group is migrating to this 5th position. So the allyl group migrates to the 5th position. So it is a Claisen type of rearrangement. So all type of condensation. So the methyl groups present in the pyrimidine ring system may undergo condensation reaction with the aldehydes. So methyl hydrogen in 2,4,6 methyl pyrimidines are acidic in nature due to the electron withdrawing effect of the nitrogen atoms. So these nitrogens are acidic in nature due to the electron withdrawing effect of the nitrogen atoms, nitroatoms. It is not nitroatoms, it is nitrogen atoms. So there are all type of condensations that occur with aldehydes. So because of the acidic nature of these hydrogen atoms, they can undergo condensation reaction with benzaldehyde to give the corresponding product 2,4,6 aryl pyrimidine. So pyridine is aromatic in nature. So pyrimidine is an aromatic heterocyclic organic compound similar to pyridine. It is one of the 3 diazynes. So diazynes are heterocyclic 6-membered heterocyclic compounds with 2 nitrogen atoms in the ring system. So pyrimidine itself has the 2 nitrogen atoms in 1 and 3 positions. So it is a solid. So pyrimidines are simple aromatic compounds composed of carbon, hydrogen and nitrogen atoms. So important compounds that are found in the living organisms containing this pyrimidine ring system are the pyrimidine bases. So cytosine, thymine and uracil. These are the pyrimidine bases which are involved in the formation of nucleic acids. So 3 pyrimidine bases: thymine, cytosine and uracil, and the other 2 purine bases, adenine and guanine, are all that are needed to produce the staggering diversity observed in many species on our planet. So matching one pyridine base with one purine base forms a base pair. Adenine always pairs with thymine and guanine always pairs with cytosine. So coming to the importance. Pyrimidine ring is found in the vitamins like thiamines, riboflavin and folic acid. So it is found in many natural compounds like vitamins, thiamines, riboflavin and folic acid. So pyrimidine derivatives have been found to be possessing diverse biological activities like antiviral, anti-cancer, antifungal, antimalarial, sedative, hypnotic, anticonvulsant and other properties. So the derivatives of barbituric acids are used as antipsychotic agents and anti-epileptic agents. Antipsychotic and anti-epileptic agents. We have various barbituric acid derivatives that have been employed as anti-epileptic agents. Some sulfa drugs also contain this pyrimidine ring system, like sulfapyrimidine and sulfadiazine. So biological importance is pyrimidine acts as nitrogen base in the synthesis of DNA. Riboflavin is vitamin B2, hence pyrimidine is present in riboflavin. So it occurs in many of the naturally occurring compounds, and it also forms a part of many useful drugs possessing various types of activities. This is about the synthesis, reactivity, and importance of pyrimidine.